Hello everyone, welcome to the first class of Conic section. We'll be starting with the topic circles. Okay, this is the one section of this chapter. The other shapes that we have to study is parabola, ellipse and hyperbola. The overall idea about this chapter is that we'll be studying equations and we'll be writing equations of these shapes based on certain conditions. Okay, so first of all, circle, how can we define it? Okay, so circle, one second. So in the circle we have a fixed point, okay, known as center. And suppose I give you that you have to move in a particular distance, means in a fixed distance, let's say r. Okay, so and this distance is fixed. That means from this point O you have to keep moving in any direction. It's just that restriction is that your distance from this point should remain constant. That's value r. Okay, so O is the fixed point. Okay, and your moving point, let's say this is P. So if we trace all the locations of P, we get this shape as circle. Okay, now let's talk about directly to the standard equation of circle. So any circle, basically anywhere, it can be in first quadrant, second or anything, by axis, x-axis. Let's say the radius is r, and let's say that the coordinate of center is h comma k. Okay, so what is the equation of the circle? The equation is x minus h whole square plus y minus k whole square is equal to r square. Okay, the value of h, k and radius r will be given to us, r square. Okay, this is the general equation of a circle with any center being anywhere. Okay, all right. Let's see one example. Okay. Find equation of circle with the center 2 comma minus 3 and radius 5. Okay, that's your first illustration. So let's see how we can solve this. So this is your h and k, that's your r. So let's put it in the equation. X minus h is 2 whole square, y minus minus 3, so plus 3 whole square is equal to r square. R is 5 square. Okay, this is the equation of the circle, or we can expand it also. So once you expand it using whole squares, you'll get x square plus y square minus 2 to the 4 na, minus 4x plus 6y and minus 12 is equal to 0. Get everything on the left, you'll get this value. Okay, if you expand it, you'll get this equation. Okay, now let's look at some of the particular cases. The first case is, suppose you have center at 0 comma 0, means origin itself, and radius is r. radius is r. So in that scenario, like, or radius, let's say, if you want to avoid the confusion, so let's say radius is the value a. Okay, so the situation will look like this on xy plane. You have a circle whose center is at origin. Okay, and the radius is a. So the equation is, if we put h and k as 0 in the above equation, this one, h is 0, so x square, k is 0, so y square is equal to r square. So it becomes a very simplified equation, x square plus y square is equal to radius is a square. Okay, if the center is at origin. So this is a one simple case. Okay, second situation, let's take if your center is, sorry, if your circle is touching x-axis, if the circle is touching x-axis at some point. Okay, so if we look at a circle, let's say, all right, this is a situation, y-axis, x-axis. Okay, radius is still r. Okay, what can you tell about the center? Center is usually h comma k. Okay, that's what we take. But if what is this condition that can be developed based on this idea? If the center is h comma k and the radius is r in this situation, can't we say this k is what, height of this coordinate is equal to the radius? Okay, I'll magnify the diagram so that you can see it better. Let's try. Let's magnify it. Something like that. Okay, I'm saying that this distance is r. Okay, and the center is h comma k. Can we develop the condition now? The condition will be that this vertical distance is the y coordinate. That means the condition here is that k is equal to r. So the equation will look like this. You don't have to learn the equation. The equation will look like this: x minus h whole square plus y minus, instead of k you will have r whole square is equal to r square. And if you expand it, of course you will get some equation in this form. But the idea is that in this situation k and r are equal. Okay, what is happening? Okay, same situation can be created regarding touching y-axis also. Okay, so this time circle is touching y-axis. Okay, so xy axis, and let's draw a circle. it can be touching anywhere on the y-axis. Okay, same idea. I'm saying that the radius is r and the coordinate is h comma k. Okay, still we can say that this distance will be the x coordinate. So the condition here developed is that h will be equal to r. Okay. So the equation will look like x minus r whole square plus y minus k whole square. Of course, he'll give you the some way to tell about this k. Okay, but this is the condition developed. Okay. Last scenario, circle is touching both the axes. Both axes. So this situation will look like this. Now the radius was r, na? This is also r, this is also r. If both the distance is equal to r, can we say the coordinate of this h comma k is actually r comma r? Okay, h is equal to k is equal to r. Both are equal to r, means the coordinate here is actually r comma r. So the equation will look like x minus r whole square plus y minus r whole square is equal to r square. All right. Let's now look at few questions. Yeah. Find equation of circle passing through intersection of a line that is 3x minus 2y equal to 1 and 4x plus y is equal to 27, whose center is 2 comma minus 3. All right. If you look at this question, first of all, we need to understand the situation. There is a circle whose center we know, 2 comma minus 3, and it is passing through intersection of two lines. Let's say this is the intersecting point of two lines. Okay. If we know this intersecting point, we can know the radius also. But first we need this intersecting point. How do we get the intersecting point? Solve these two equations, 3x minus 2y equal to 1 and 4x plus y equal to 27. Solve these two. So multiply this by 2. So 3x minus y equal to 2y equal to 1. 8x plus 2y equal to 54. So add them, you will get x 11x equal to 55, x is coming 5, and if x is coming 5, you put it in any equation, you will get y as, sorry, x is coming 5, y is coming 7. Okay, so now we have found the intersecting point of these two lines. Okay, we know this point, we know this point. We can calculate the radius using distance formula. So radius is square root of y2 minus x2 minus x1. So 5 minus 2, that's 3 square, and 7 minus 3, that's 10 square. So it's coming square root of 109. All right, and equation of circle will be like x minus 2 whole square, y minus 3. Okay, this is h comma k na, so using the standard form is equal to r square, that's 109. Okay, you whole square. You can expand it and get it in the simplified expression, everything on the left side. That can also be done. Okay, okay. Now, if you actually open this kind of equation, you get x square, y square, some factor of x, some factor of y, some constant. Okay, so another way to represent an equation of circle okay, is, again we are talking about equation of circle, but this time in the expanded form. Okay, so if we expand that, the equation will look like this: x square plus y square plus 2gx plus 2fy plus c. Okay, don't worry about this 2g 2f, it is represented for your simplicity effectively. We can represent as gx and fy also, but then you'll have to slightly complicate the things that we are going to calculate. Suppose right now what we have done is we are calculating equations out of this conditions. What if the equation was given to us and now he asks us, suppose this is the equation of a circle, and he asks what is the radius and what is the center. Now in order to get that, somehow you have to convert this into this form or use these formulas, which makes things easier. Center for this equation is minus g comma minus f. Okay, it is coming x minus minus g comma minus f, and radius comes square root of g square plus f square minus c. Okay, this is the reason I was telling you to consider the coefficient of x as 2g, not g, because otherwise this expression will become complicated. So this will help you a lot to quickly calculate the center as well as the radius. Let's see how it helps. Let's look at one question. Find center and radius of x square plus y square minus 6x plus 4y minus 12 equals to 0. This is the equation. You need to find center and your radius. So first of all, let's compare it. The coefficient of x, 2g is minus 6, so g is minus 3. Similarly, the coefficient of y is 2f, which is 4, so f is 2. Now center is minus g comma minus f, so change the sign, 3 comma minus 2. Simple enough. Radius, square root of g square plus f square minus c, so square root of g is minus 3. So 9 plus f is 2, 2 square is 4, minus c is, this is our c, okay, c is minus 12. So minus minus 12, so it will become plus 12. So 16 plus 9, 25, root 25. What's root 25? 5. So radius is coming 5. Okay. All right. Let's see one manipulation of this. Find same thing, center and radius. Okay. This time the equation is 2x square plus 2y square plus 8x plus 10y minus 39. Okay. And you have to tell where is the center in terms of coordinate and radius. Now you cannot use this time directly this, that this is the coefficient of x, so this is 2g. No. Why not? Think of yourself. First of all, the equation consists of x square plus y square, means the coefficient of x square and y square should be 1. Here it is not. So it's our work to make them equals to 1. So for that, how do we do that? We'll divide this whole equation by 2, both sides. Okay. So if we divide the whole equation by 2, what do we get? X square plus y square. Instead of 8x, now you get 4x plus 5y minus 39 by 2. And yes, fractions are there. Now you can say that the coefficient of x and coefficient of y, they are 2g and 2f. So g is half of it, 2, f is half of it, 5 by 2, c is minus 39 by 2. Okay. Now directly center is minus 2 comma minus 5 by 2. Radius, yes, it will take time, square root of g square plus f square minus c. Let's calculate. So square root of 4 plus 25 by 4 minus of minus 39 by 2, so plus 39 by 2. Let's calculate. Square root 4, 16 plus 25 plus 39. 25 plus this 31, 41, 50, 80. So square root of, it is coming 80. Minus 39, no? Radius they have not asked. Why? Okay, they haven't asked it, but yes, it will come. They have asked for the equation of concentric circle with something like that. Anyway, so 16, yeah, what we calculated, 16 plus 25, 31, 41, 50, 80, 80 by 4 is 20, okay, and square root of 20 is 2 root 5. So let it be. It's not like the answer cannot come in fraction. Okay. All right. You're done. Nothing else. So now we know how to calculate radius and everything. There's one more form known as diameter form that will help you in the exam. Okay. Again, another way to represent equation of circle. It's called diameter form because it takes help of idea regarding the diameter. It's diametric form. Okay. So first of all, let's understand the situation. You need to write the equation of a circle. in which this time he has given you 2 points and equation of a circle on a straight line. Okay, so he has given you the endpoints of diameter. Okay, this is x1 y1, this is x2 y2, and they are the endpoints of the diameter, and you have to write the equation of circle. Of course, what you can do is find the midpoint, so you'll get the center, then use distance formula to calculate radius, and then calculate the equation using the earlier form. But this one is much more quicker. The format goes like this: x minus x1, x minus x2 plus y minus y1, y minus y2 is equal to 0. As simple as that. Let's see one example of it, how to use it. Find equation of circle passing through find equation of circle in which coordinate of endpoints of diameter is -1, 2 and 4, -3. Alright, let's use it. Okay, so the format is, this is our x1 y1 and x2 y2 na endpoints of diameter. So x minus x1, so minus of minus 1, x plus 1, x minus 4 plus y minus 2, y minus 2, y minus minus 3, okay, is equal to 0. Open it. This becomes x square minus 4 plus 1 minus 3x minus 4. This becomes y square plus y minus 6 equal to 0. So combine it, x square plus y square minus 3x plus y okay, minus 10 equal to 0. Now he can ask you for the radius also. You can directly calculate using the method that I just taught you, using the standard equation x square plus y square plus 2gx plus 2fy, using that also. Or you can calculate the center using midpoint, okay, and then calculate accordingly. Okay, that was diameter. All right. Now, as such, if we look at a circle, it divides this plane in three points, in 3 sections as such. Okay, this is outside, inside, and this thing is called on circle. Okay, so how do we know the location of a point, whether it is on the circle, inside the circle, or outside the circle? So location of a point. Okay, so the question can ask you whether the point is outside the circle, inside the circle, or on the circle. Let's take one very simple equation to understand. Let's say the equation is x square plus y square is equal to 3 square. Now we know if it is x square plus y square, the center is at origin and the radius is 3. Okay, and suppose the question says find location of points. First one is, let's say 1, 2. Second is 3 now. So 2 comma 2 comma 3. Okay, let's take 2 comma 3. Then let's take last on the circle now. Third one, let's take 3 root 2. Three by root 2, or let's take 3 by root 2 by comma 3 by root 2. Let's take, I'm creating the points to make you understand this concept. Okay, first one, what do? You have, in order to calculate this, first of all, if a point x1 y1 lies inside circle, so the x square plus y square, okay, is less than the radius square. If x1 comma y1 lies on circle, so it will satisfy the equation, is equal to r square. And third, if x1 y1 lies outside circle, then x square plus y square will be greater than r square. Okay, so let's see. First, let's put it in the equation. X square, x1 square, sorry, this is x1 square, y1 square, x2, sorry. So basically what you do is you put the coordinate in equation. Okay. So let's put 1 comma 2 in the equation. So 1 square plus 2 square. Okay, forget about equal to, right side is 3 square. 1 square is 1, 2 square is 4, 5, this is 9, this is 9. So it is coming less. So if x1 square plus x2 square, it is coming less than the radius square, that means inside. So this point lies inside the circle. Second one, 2 comma 3 na, so 2 square plus 3 square, right side is also 3 square, so this is 4 plus 9, that's 9, so 13 and 9. Clearly this one is greater. If it is greater, this means the point is outside the circle. And 3 by root 2, 3 by root 2 na, so third one, so 3, I think I created a wrong point. Let's see, maybe 9, 3 by root 2 whole square plus 3 by root 2 whole square, right side is 3 square, so 9 by 2 plus 9 by 2, it's correct. So 9 and 9, so they are coming equal. Equal means it is satisfying the equation, hence it is on circle. Okay, so this is how you can know whether the point is inside or outside the circle. All right. It's done. Okay. So I'll end the session because parabola, ellipse, hyperbola, they have slightly different idea. The theory part is much more greater for the circles. As such, there is not too much theory. If I'll have to conclude, I say you have one standard equation majoritively used to create the equation. Okay, x minus h y minus k whole square is equal to r square. Then these are the special cases. Okay, these are not formulas. Then equation of a circle in general form, so how to calculate center and radius directly. Okay, and then this diametric form. That's it. Okay, fine, let's end this session here. We'll continue this chapter in the next class. Okay, all right, see you in the next class. Good day.